Example 2r. Find the equation of the line that is perpendicular to the line 2y plus 4x minus 8 equals 0 and passes through the point -1, -3. So we're looking for a line which is perpendicular to this equation, or this line, but passes through this point here. So our very first step when doing this is to take this equation and rearrange it into this form, y equals mx plus c. So doing this, I'm going to minus the 4x and plus the 8, and then divide by the 2, leaving me with y equals -2x plus 4. Our next step is to identify the gradient of that first equation, so m1. And we can do that by reading it straight off that equation that we rearranged. So -2 is going to be our gradient. We now need to substitute in the gradient of the original equation into our formula m1, m2 equals -1, our perpendicular formula, to calculate the gradient of the perpendicular line. So m1 is -2, m2 we're trying to find. Rearranging, we get -1 divided by -2, which is just the same as 1/2. So our perpendicular gradient is 1/2. We now need to label our coordinate point -1, -3 as x1 and y1. That, along with our perpendicular gradient, can be substituted into the equation y minus y1 equals m bracket x minus x1, which we can then rearrange to find y equals mx plus c, the equation for the perpendicular line. Now doing this, y minus -3 is equal to 1/2 bracket x minus -1. That's our formula with everything substituted in. Simplifying that a little bit, we get y plus 3 is equal to 1/2 x plus 1, expanding the brackets to get 1/2 x plus 1/2, and moving that 3 across. Now to combine that -3 with the half, we're going to convert that 3 into a fraction. So -6 on 2, minus the numerators will give us -5 on 2, which is actually our end answer. So y equals 1/2 x minus 5 on 2. This is the equation of the line perpendicular to the original equation we were given.